You know, so it goes faster. This should go close to 15 or something like that. Let's see what happens.
Oh, you're loading now, right?
I'm loading now. So we already have 1,500 pounds.
Oh wow, it's going real fast.
Hopefully the specimen won't slip. We had that problem before, but I don't think it's going to happen this time.
Still got a while. It breaks, it fails on the rate.
Okay, so we're on our way.
Yeah.
As you can see, these numbers are higher here. You know, the specimen is stiffer than the aluminum, so we can...
Yeah, it's already past it.
It jumped
Something
up.
happened here. I think it
Slip.
kind of slipped a little bit or something. That's right. But it engaged and with a vengeance. As you can see, these numbers are fairly high, so the material is stiffer than aluminum. It's still stiffer than aluminum. That means that a smaller increase in displacement, you know, produces a higher increase in load. So there we have it. And this is going on.
Why did the slope change after the slip?
I'm not sure.
This is jump. It may be, if you drew the line, it might be like, yeah, you have to fit that. That curve needs to be fit.
Yeah, probably something like that. Okay, so we are now below 100 here. So that means that the slope is starting to change, starting to plateau slowly.
Actually, what happened is the specimen was not in its own place until it was secured, then it's gaining its own stiffness.
Okay.
Okay? So the initial stiffness, that was not a...
Right, it was, you know, not quite yet.
Oh yeah, it is.
Now, according to this thing, it's starting to plateau now, but since the load seems kind of small.
I got 10,000 pounds on it.
Thought it was going to go a little bit higher, but let's see.
It jumped up again.
Yeah, I think it slipped or something because it was going negative. That's
No, it's
weird.
still going up. It's still around 44. So it went down a little bit here, but you know, it's
Well, that's your class. So now it's hard. Now you're in hard.
oh, there you go.
Hardening agent. So,
One right before it picks up.
oh, and then
In the
before
grass.
it goes flat.
Yeah.
One break.
So we're doing 13,000,
Oh, man, dude.
you know, and we still have a pounds per second. The rate of pounds per second is around 26, 29 average. Trying to keep the load rate at 0.005. Yeah, the problem is this thing keeps changing the scale, you know, to match this thing, so the perspective changes. And as you can see, the stiffness is going down, this thing is plateauing again. We were at 40 something, right now we are at 15, 17. We're at 14,000 pounds.
Good.
I saw something new, but
The
Handle went down.
I don't like
It did that last time
They
too.
did that after, yeah.
Already? Oh, okay.
What it is, this specimen will need to be secured in a timely manner. We did this in Russia within half an hour. So that's why all these things are happening. It needs to be very well secured. But he's doing his best to get everything out there for you in half an hour. So that's
You see how it's falling?
But it's still holding its own, you know.
Little pieces
We're
are going
close
down.
to 15,000. We're 14,790. But as you can see, we have values now around 3, 5. So it's plateauing now. So yeah, I was, you know, my initial guess was right at close to 15,000. So I expect we're going to see the same thing. You know, this is going to hold. These numbers going to hold for a while. Then it's going to start to go down. We're going to see the necking. Boom. Let's see if that's true.
What are the shavings coming from?
Well, you know, you have some corrosion in the surface, which is brittle. It's not as, you know, it doesn't have the same plasticity as the steel. So it's just basically, yeah. Okay, so the load is not going up any longer. We have 14,878. That's it. That's the maximum. Hold it back. Okay. Yeah, you can explain that. The load rate's negative. That means, as you can see, the graph is starting to go down. So we need to watch out for the necking, you know, the changing in diameter. Oh, there you go.
Right in the middle.
Yeah.
Actually, yeah, it's close to the center, not too bad.
Whoa.
There it goes.
We're right now at 14,000 and going down.
So the shavings are coming off the front too.
Yeah.
It's going down pretty fast, 120 pounds per
There it goes,
second,
there it goes.
but negative.
It'll
12,000,
be coming out of top.
It's not going. You can tell.
11,
It's just gonna go clink.
10,
Oh.
and that's it.
Can you pay attention here? This point is your yield point right here. Okay? This point is your yield point. This second stiffness is the real stiffness, because in the first stiffness, the specimen was not really tight. It was not secure. It took a while until the specimen became secure. So this is your real stiffness, and this is your yield plateau. This is the strain hardening, and this is the softening. Okay, this is exactly what we covered in class. Except in this case, your yield plateau is very small, and that's a behavior of that particular steel. Normally, the yield plateau should be much longer than what we're seeing here, but that is steel, whatever the steel is using there. But the shape is the same. This should not be two regions. This is only one region, and that is because it was not secure. It took a while until the specimen became secure. That means he didn't have it secure initially. If it was initially very, very secure, this would have been a straight line. So your stiffness is really this one. You need to kind of figure out your stiffness from this line. You can get 2 points on this line and get your stiffness. In here, your stiffness should be very close to 30,000. On the aluminum, it should be very close to 11,000 KSI. Units are KSI, not SI, okay, KSI. Okay. Now he's going to break a cylinder for it. Take a picture of that. We will be looking at the stresses of relation to the failure here.